Okay. Okay, you can see it there. So today's topic is DeFi intent from a solver. For those who aren't familiar with Enso Finance, we are a solver for CowSwap, the OGs of intents. And Enso also offers one unified API to interact with DeFi, ranging from lending, borrowing, vaults, LPs, swapping, and so forth. This is also compatible with EOAs and also smart accounts. What are intents? Intents are a very abstract term, generally implying your intentions, what you'd like to do, and this involves many different parts. So we like to focus on DeFi in particular. There's many different challenges within DeFi. As of today, the intents can help along this path. Number one is UX flow. Number two is how 4337 bundlers are actually broken for DeFi. And users are unaware of opportunities within DeFi. Let's take a very basic scenario of a very basic DeFi flow. I'm a user, I have Y token, and I want to enter into X beefy position. First of all, I need to know about beefy. Second of all, I need to know all of the protocols that are required to be able to enter this beefy vault. I'll go to Uniswap, I'll approve my tokens, and then I'll swap into the underlying tokens of the Balancer vault. I'll then go to Balancer interface, approve my tokens, deposit my tokens into Balancer. Third step, I'll then approve my Balancer LP onto Aura, deposit my tokens into Aura. Fourth step, finally get to my end destination where I already knew where I wanted to get to. I need to finally approve my tokens in Beefy and then finally deposit into Beefy. This is what success looks like within our current industry of DeFi. 4 different interfaces, 8 different transactions for a very simple DeFi flow. This scales to tremendously bad user experience the more DeFi actions you do. In a case of entering 2 beefy vaults, lending on Aave, borrowing on Aave, hedging your position on IPOR with Fixed Yield, doing perps all within one transaction, take you a couple of hours, probably get a couple of gray hairs, and many different user experience journeys. Oh, one other solution you could say, okay, maybe user experience is bad. Why can't we just batch all of these transactions together into one using 4337 bundling techniques? I would go to Beefy, I would go to Uniswap, step 1 again, approve, add my approval into the queue, and then I would assume that I would be able to swap into the underlying tokens as before. But as my approval is still in the queue, the state has not been updated on chain, so users blocked. Sure, all these interfaces do RPC requests to the chain to get the most updated state to present to the user, so like toggle availability of using a swap and so forth, or they rely on subgraphs for this. Sure, you can hack around this. We've done it back in January. You can do RPC hijack requests, so you can allow the user going through their whole flow. Anything they want to submit, you submit it to a fork, you actually run it on the fork, you take into account of the percentage of the assets used inside of there, you work out the percentages of tokens coming out of function call 1 into function call 2, allowing the user going through this whole flow to then submit it as one. It's pretty hacky, it's not very nice. Or, which makes even more sense, you just fork every single subgraph and run every single subgraph for every single DeFi protocol. You can see this really doesn't scale for user experience. In this scenario, again, where we started was first entering a basic DeFi vault, a beefy vault. Now with intents, we can abstract all of this complexity of user experience away. You can simply go to an interface like CowSwap and state your intent. I have Y token, I want to go into X beefy vault. Whenever you state this intent, this will go into network, this will be picked up by solvers, and whoever can fulfill this intent with the best amount out will then be able to submit the order. What solvers do underneath, it could be anything. The user ultimately doesn't care. All the user cares about is getting this desired outcome. So solver may do on-chain routing, they may use their own float, they may be plugging into market makers, they may do some MEV, they may do some arbitrage, they may do whatever they would like to do, as long as they fulfill the desired order, which increases order efficiency of this whole ecosystem matter of 10x, 100x. Intents really are only being spoken about for execution, but I see personally that there's many different layers of intents, and I don't think they're being given enough discussion around. For me, there's four. There's the interface. Maybe this pointer works. Yeah, there we go. Okay, well, you see it anyway. So interface, interpretation layer, data layer, and finally the execution layer. The interfaces can be as simple as swapping from token A to token B. It could be a multi-swap, or it could be a project similar to Lang Wallet that will allow you to, I think that's increasing volume, allow you to kind of go voice to text and then text to action. And you can also put in different parameters such as if ETH reaches this price, then buy these tokens, so similar to automation. There's many different types of interfaces that can do these text actions. So you can have like, show me the best APY for USDC. The user doesn't care what protocols are underneath. They only care about making money. Get me a stablecoin that I can cash out through Coinbase and sell 10 ETH. Sell all positions that have exposure to a particular protocol. So if a protocol in DeFi gets hacked, pretty sure everyone's aware, then most of the ecosystem is just Russian dolls. So if one protocol gets hacked, then many get affected by this over time. You could even set different criteria on these interfaces, do 10x leverage long on for 200K if USDC depegs to 85 cents. This was a great trade, by the way. Then you have the interpretation layer. You, first of all, kind of need to understand what the user is asking. And to understand what they're asking, you need to know what they've previously done and what their kind of intentions were based upon the outcome that they actually wanted. So you can use different language models, different AI tools for this. And to be able to do this, you get to the stage of prediction models. And this gets a bit scary. Since everything is fully on-chain of everything that you've ever done, and you've stated what your intentions were, and you selected what actions were your true intentions, you are categorizing yourself as a human being. And if you start, let's say, scanning your irises and having an identifier associated to your full on-chain data, this can be used against you. So this has been known within the Web 2 ecosystem for 10, 12, 15 years, where these recommendation engines are able to determine from your previous actions what the future of you is going to do before you even know it. So they were able to determine back in 2012 of a teenager, she didn't even know that she was pregnant. But based upon her actions and her intentions of looking at different products and so forth, then they were able to kind of send her an email, say, congratulations on your new baby. She didn't even know she was pregnant. If you want to have a look into this, highly recommend a great book called Data and Goliath. The more data you start associating to your financial transactions and your intentions to, again, an iris, is very problematic. Right now in the solver ecosystem, generally speaking, it's only tokenized positions. So certain DeFi protocols are tokenized, some are not. So for example, lending on Aave is tokenized, borrowing in Aave is not tokenized. You do get a token at the end, but the state of your borrow and your liquidation ratio is associated to the address and interacting with it. However, Aave does have kind of delegations. You can delegate this borrow to somebody else and so forth, but there are protocols that do not allow you to do this. So in this case, for example, Liquidity, they do not have delegations. So I personally see the ecosystem of solvers also evolving more into smart accounts, in particular with the safe ecosystem. And with that, by stating your intentions that are tokenized and state changes, then you can do all of these bundles and outcomes within one transaction. Where Enso kind of plays into all of this. So Enso you can envision as a one unified API to interact with all of DeFi. So we are a middle layer that abstracts all of the complexity away if you want to interact with DeFi. So instead of building your own manual integrations, you can simply just plug into our API for this. Without Enso, you're looking to time to market for every single DeFi protocol, 4+ weeks, writing custom indexers, writing custom metadata services, and you're also paying hundreds of thousands of dollars on audits. With Enso, you plug into one API, you get hundreds of DeFi protocols out of the box. DeFi, as of today, on DeFi Llama, is 2,909 protocols, most likely on-chain. There's probably 10,000, 15,000. And our view of this ecosystem will be propelling into hundreds of thousands of DeFi applications on a daily basis. We have all the execution side and also all the metadata. So we have projects such as Lang Wallet that are using this data to build their own interpretation layer, to build their interface, to then translate into an intent of execution. This is kind of what our architecture looks like. You will call our API with all of the actions you want to execute, whether this is an LP, borrowing, lending, and then you will get the best order of routing, and you will get the call data back. Everything is simulated, so we run it on Tenderly, and we also built our own open source simulator because we were getting throttled. So if you want to use this, feel free to just use it. Here's the Git repo for the simulator. Spin it up. It's a REST endpoint built in Rust on top of Foundry. Thanks. So a short talk, but I want to give some time for questions. And we have a booth, so if you have any more questions there, feel free to come and talk to us. And we're also doing a workshop on Wednesday of building a DeFi Telegram bot using the Enso API. Thank you.
Thank you, Connor. That was quite interesting. Of course, I agree with you. One of the biggest challenges when you want to use something in DeFi is the number of steps you have to take. And I myself have dropped out multiple times before executing the transaction. So now we have some time for questions. Anybody? Yes.
Hi, hello. I'd like to know for the simulation, I don't know if you mentioned it, but where do you get data from and how do you process it before simulation?
In what regard? So like the address of the protocol you're interacting with, the function signatures?
Yes, yes. And what's, I mean, the data source itself? Do you make query to subgraph to make the analysis, or how do you manage all that?
So let's say factory addresses of new vaults or new protocols that get deployed. We have custom indexers for this. The metadata service, we collect it from many different sources as well, such as Subgraph, DeFi Llama, Nanolay, about 6, 7 different sources for the metadata. The simulations aren't really related to this. The simulations are purely to validate the function signatures that are being called, the relationships of the contracts, and also all the addresses are functioning correctly. By doing these simulations, it's even more important since we're encoding all these calls off-chain to put on-chain. It's a similar architecture as Universal Router. Universal Router is kind of a middle layer to interact with all of their pools, and off-chain's the logic for all the graphing and so forth. And our simulations are to validate that it does pass correctly, what contracts are being called, the amount out, the amount in, any failures, and so forth. And you will only get call data back if it passes.
Thank you.
It seems like you're trying to capture like the whole vertical stack of the DeFi experience. On your roadmap, have you guys been paying attention to the idea of like running your own Ethereum nodes and perhaps giving some sort of like special, like maybe like MEV bonuses to the users of Enso? So if you guys get a big treasury, you could start, you know, offering like MEV incentives and start disincentivizing everyone else?
Yeah. If they're kind of wanting MEV protection, I'd highly recommend to go to CowSwap. This has it out of the box, and we're a solver, so we don't need to manage that part of the stack. We do run kind of some of our own nodes for faster throughput of indexing and so forth, depending upon liquidity of dexes. But if you want MEV protection, Cow's your guy.
I want MEV like addition. I want you to give me MEV value just because I'm using Enso.
Yeah, I mean, we are exploring this to a certain degree. Yeah, maybe we'll write a research piece and publicize it. Yeah, thank you.
Any further questions? Anyone? All right. So, Connor, that was a pleasure.